Implicit differentiation. We are now going to turn our attention to equations which are expressed or written in implicit form and learn how to differentiate them. Now that we better understand what the notation dy dx truly represents, we can begin to work with equations that are in implicit form. Implicit form is when an equation is not solved for any one particular variable. For example, the equation below is in implicit form. 2y cubed is equal to 4x to the fifth plus 9x squared. In the lessons that are upcoming, we're going to learn how to differentiate such equations. In this example, we are going to find dy dx of 2y cubed is equal to 4x to the fifth plus 9x squared. When we differentiate 2y cubed, that gives us 6y squared, and then immediately after that we multiply by dy dx. A professor in college once told me, always remember when you differentiate y with respect to x, you need to write dy dx right after that. On the other side of the equation, 4x to the fifth gives us 20x to the fourth, and 9x squared, the derivative of that, will be 18x. However, we are not done. We were asked to find dy dx, which means we need to divide both sides by 6y squared, and the final result will be dy dx is equal to 20x to the fourth plus 18x divided by 6y squared. Let's take a look at implicit versus explicit differentiation, and we're going to compare two methods. For explicit, we're going to start out with the equation x squared plus y squared is equal to 25, and we solve for y. That gives us y is equal to plus or minus the square root of 25 minus x squared. When we differentiate that and simplify, that's going to give us negative x divided by the square root of 25 minus x squared. And just point out that this was plus or minus the square root, so the positive case would also work out as well. We actually have two different derivatives, negative x over the square root and positive x over the square root. That's what explicit differentiation looks like. Implicit differentiation, we still start out with the same equation, x squared plus y squared is equal to 25, but we differentiate it term by term. The derivative of x squared is 2x, the derivative of y squared is 2y, and we don't forget our dy dx is equal to 0. Then we solve for dy dx, which is going to give us dy dx is equal to negative x over y. You can see the algebraic steps in between. Now, you might originally at this step ask, well, this looks totally different than what we have over here. However, if we substitute in for y, we notice that when we put y, replace y with plus or minus the square root of 25 minus x squared, we actually do end up with the same result.